discussed about these five languages, then functions, operators, constraints, some important queries, right? Okay. Yeah, yes, Pratap, you have anything to ask? It's clear, right? You can hear me, right? Okay, okay. Yeah. Sharwani, you have joined through web, so if it is possible, you can switch to desktop version. Okay, fine, sure. Okay, some important queries. Next. Today we are going to start with views. Okay, what is view and how to use these views, in which scenarios we have to create these views, that we will discuss. Fine. So view is a logical object. What is view? View is a logical object. So what is meant by logical object and why we create these views? View is a logical object and views are created to hide confidential columns in a table. I repeat, view is a logical object and these views are used to hide the confidential values or confidential columns in a table. For example, let's say there is one front-end application, HR application, and this is a database or a table, employee table. Okay, so this is HR application and this is employee table. Whatever the data is going to submit through this HR application, so that data is going to be loaded in this employee table. Okay, so now in this employee table we have some of the columns like employee number, employee name, salary, email, phone number, address. Like this we have some columns in this employee table. Okay, so only HR will be having the access to access the employee table data or to insert the data into this employee table. Okay, you are the Java or .NET developer. Okay, so you have developed another application. You have developed one application, front-end application. So this is Java or .NET application and this application wants to test. Okay, and this application wants to access this employee table data. Someone already developed this employee table and HR application and currently this is in production environment, and you have developed one more application, front end application. You want to test this application by accessing this employee table data. So to test this application, we are not going to directly test in production environment. We clone the data or we copy the data from higher environment, that is from production to UAT or QA or into dev environment. Okay, let's say, so DBA, they have created a copy of this employee table from production to dev environment or QA environment or UAT environment. So they have created a copy of this table in the lower environment, and you have developed one front-end application, and this front-end application now wants to test. Okay, so if I am the DBA and if I am going to give the access to you on top of this employee table to access the employee table data or to test your application by accessing this employee table data, then you will be seeing, or you can able to see all the employees data, right? So whatever the data here we have in employee table, like employee number, employee name, salary, email, phone number, address. So here some of the columns we have like salary, phone number or email ID. So these columns are confidential columns, right? So if I am going to give the access to all the developers who is working on this application, then they can able to see the confidential data. So this data we have copied from production environment, and now if I am going to give the access to this table to test your application, you can able to see the confidential data, so which I don't want to share with anyone. Okay, so I have this table, and in this table some of the columns are confidential columns, but someone is requesting for access on top of this table. Someone is requesting access on top of this table. Okay, so now what I have to do as a DBA? So I have to give the access on top of this employee table, but I want to hide confidential columns in this table. So after hiding the confidential columns like salary, email and phone number, these three columns I want to hide, and I want to give the access to the developer on top of only specific columns, employee number, name and address. So I want to give the access on top of specific columns, not all the columns in a table. So I want to hide some of the columns. Okay, so now this developer, he can able to see, suppose let's say if you have 100 rows in this employee table, he can able to see all the 100 rows, but he cannot able to see salary, email and phone number if I am going to hide these three columns. So why I want to hide? Because these three are the confidential columns, so that's why I want to hide some of the columns in the table, and for the remaining columns I have to I want to give the access. So for that, what we have to do? So if you want to hide some of the columns, and if you want to give the access, or if you want to retrieve the data from specific columns, then what we have to do is we have to create a view on top of this table. Okay, so how to create a view? So to create a view, we have to write a query like this: create view, view name emp underscore v as select employee number, employee name, address from employee. So this is the query to create a view. So if you execute this query, then you will be getting the message view created successfully. Once the view created successfully, so this is also like a table. So with the name emp underscore v will be created, employee number, employee name, address. Suppose if you have 100 rows here, the same 100 rows also will be there in this view. Now we call this as a view. So view from where we have created? From this actual table or a base table employee. Okay, so from actual table we can create a view. View contains limited columns, not all the columns from the table. So now if I am going to give the access to this view, now this developer, whatever he developed the application, he can test his application by accessing only limited columns data, but he can able to have all the employee IDs. So 100 employee IDs are there in an actual table, the same 100 employee IDs will be there in the base table also, that is into the view also. Okay, but he can able to see only some of the columns, not all the columns. So because we don't want to give the access on top of all the columns, because some of the columns we have confidential data, so we don't want to share with that data with anyone. For testing purpose or for some other purpose also we don't want to share. So then in this case we create a view. Okay, so now view created. Now if anyone is requesting for access on employee table, now instead of giving the access on employee, you can give the access on top of view. Okay, so now you can give the access on top of view. So now once the view is created, now developer can access this view. Okay, so after giving the access on top of this view, now developer can access this view. Fine. Next, so view created, table will be created in a database, right? So the tables, where it will be created? It will be created in a database. What about view? So view also, now we have three columns with 100 rows. Suppose if you have 100 rows here, the same 100 rows you can see in this view also. Now we have a view with three columns and with 100 rows. Now where this view created? Views always will be created in temporary memory. So that is the reason we call this as a logical object. Logically it will be created. you cannot see the view. So if you want to see the view data, you just have to write a query, select star from that view name, view name. So if you write that query, you can able to view you can able to access, or you can able to see how many rows are there in view and what are the columns are there in a view. Okay, so where views will be created, views always it will be created in temporary memory. So that is the reason we call view is a logical object. Logically it will be created in temporary memory. Since views created logically in temporary memory, we cannot perform any DML operations on top of view. Okay, so no DML operations. Views created logically in temporary memory, we cannot perform any DML operations. What is meant by DML? Insert, update or delete. So you cannot insert the data into a view. So actually if you try to insert, it will allow to insert 1A 100, suppose let's say if you try to insert a record into a view through the front end application or by executing an insert statement, yes, it will allow. But generally why we insert a record into view means this record should also reflect into the actual table. As soon as we insert a record into a view, the same record also should insert 1A, some like this. Okay, for these columns we are not passing any values, so like this it should have to insert. So if it is allowing you to insert a record into the actual table, that means then we can able to perform DML operations, or we can execute DML commands on top of views. But here view will not allow to reflect the data from view to actual table. So even though it allows you to insert a record into a view, it will not allow to insert the same record into the actual table. So you can just insert that data into the temporary memory, right? So but that record we cannot expect it to have the same record into the actual table, because this view created based on the actual table. Whatever the operations we perform on top of view, the same operations immediately it should have to reflect into the actual table. Or if you perform any operations on top of actual table, the same operations also it should have to reflect into the view. But here view will not allow to insert a record. Whatever the record inserted in a view will not insert that record into the actual table. Okay, so that is the reason we call view will not allow to perform DML commands or DML operations. Okay, so we have front end application and we have given the access to the developer on top of this view. Okay, now he can able to see all the 100 employees data. Okay, then he is expecting whatever the record he is going to insert through this front end application into this view, the same record should immediately reflect into the actual table. So for that what we have to do, I repeat, as we discussed, view we cannot perform DML operations on top of views, because view is created logically in temporary memory. So that is the reason we cannot perform any DML operation. Even though if it allows you to insert a record into a view, that record will not reflect into the actual table. Whereas now whatever the record inserted through the front end application into a view, if you want to reflect that record into the actual table, then we have another type of view called materialized view. So we have another type of view called materialized view. Okay, so if we create a materialized view, this is a physical object. So materialized view is a physical object. Okay, same, create in place of view you should have to write materialized view name emp underscore mv as select employee number, employee name, address from employee table. So if you execute that query, materialized view will be created. Where it will be created? Materialized views will be created in a database. The way how tables will be created in a database, in the same way materialized views also will be created in a database. So you can see what are all the materialized views created in a database, whereas views will not create in a database, it will be created in temporary memory. So since materialized views physically exist or physically created inside a database, so if we have a table structure or materialized view in a database, we can perform any type of DML operations on top of materialized views. As soon as we insert a record into a materialized view, the same record, it is also going to be reflected into the actual table. Okay, so if you create any constraint on top of materialized views, the same constraint also going to reflect into the actual table. If you insert any record into your actual table, immediately that record also going to be loaded into the materialized view. So these two would be in a sync, but not views and actual table. So that is the difference between view and materialized views. So we are informatica developers, we are not going to create any views and materialized views. This is very important interview question from SQL for informatica developer. So they might ask, what is the difference between view and materialized view? Okay, so view is a logical object, materialized view is a physical object. View will be created in temporary memory, whereas materialized view will be created in physical, like that is in a database. Since view created in temporary memory, we cannot perform any DML operations, even though if it allows us to insert a record into a view, so that record is not going to reflect into the actual table, whereas whatever the records or data or constraints which we are going to insert into the materialized view, the same it is going to reflect into the actual table. Okay, so that's all about views and materialized views. You just have to know the definitions. So this is important for interview from SQL. Fine, clear? Any questions? Clear, right? Next, joins. So SQL joins, we have joins in SQL like this: normal join, inner join, and equi join. Okay, left outer join, right outer join, full outer join. So these are the different types of joins we have: normal join, inner join, equi, left outer join, right outer join, and full outer join. So why joins are required? So joins are required to join two tables. If you want to access multiple table data by joining, then we should have to use any one of these types of joins. Okay, so now let's say here we have a table like this: employee table, employee name, department number. This is employee table, and we have department table like this: department number, department name. Sure. Finance. So like this we have two tables: employee table and department table. Okay, so to join two tables or three tables or any number of tables, we should have common column, right? So without having common column, we cannot join. There should be some common column to join the tables. So here the common column is department number. So based on this department number, we can join these two tables. So first let's start with normal, inner, or equi join. So any idea what is normal join? How it returns the output? Y- yeah, so it returns matching records from both the tables. So it returns matching records from both the tables. Okay, SQL query, so that is the definition. SQL query, select star from emp e. Okay, join deptt on e dot department number is equals to d dot department number. So you can see here we have e. After table name we have e. What is the c? This we call it as a alias name, table alias. This is the table name, and after the table name if you write any character like this we can call it as a table alias. Why we need table alias? If you are joining two tables, or if you have multiple table names in a single query, so we have this single query. If you have multiple table names in a single query, and again, so those table names we are going to access, or we are going to write, or we are going to use those table names in joining condition. So here I have written e dot department number. So even though if you are not going to write e here, it is going to work, but here in place of e you have to write the table name emp.dno is equals to, in place of d you should have to write dept.envo. Instead of writing that much big name, we are just writing that character. So here we have table name only 3 characters, but in real time you will be having the table name 10 characters, 15 characters, or 20 characters of table name. Okay, so if you have that much big name, so again you have to write full table name here. Instead of writing that much full table name, we just use the alias name like this. So if you have more than one table name in a query, then it is suggestible to write or to use the alias names, and instead of writing full table name here, you can just use that alias name, right? Okay, so now here we have join. So if you write simple join here, then we can say this is a normal join, or inner join, or equi join. Okay, now what would be the output? Since I have written star, it is going to display all the columns from both the tables. Okay, employee number, employee name, department number, department number, department name. Okay, and what is the first record? Matching records from both the tables. So matching records means, since based on this condition, what it will do, it will take employee table department number, and it will search in department table department number column. 10 with 10, is this matching? Yes, this is matching, so it will return that record. Next, 10 with 20, is this matching? No, this is not matching. Next, 10 with 40, is this matching? No, this is not matching. Next, it will take the second value. 20 with 10, is this matching? No, this is not matching. Next, 20 with 20, yes, this is matching. It will return that record. Next, 20 with 40, is this matching? No, this is not matching. Next, it will take the third value. So 10 with 10, is this matching? Yes, this is matching. Next, 10 with 20, is this matching? No. Next, 10 with 40, no, this is not matching. Next, 30, do we have any matching record? No, we do not have any matching record. So now how many matching records are there in both the tables? We have 3 matching records. So the output would be like this: 1 A, department number 10, 10, department name, it is HR. Next, 2 B, 20, 20, accounts. Next, 3 C, 10, 10, HR. That's it. So these 3 are the matching records. So this is the output of normal join. Okay, next, there is some difference between normal and equi join. Do you have any idea what is the difference between normal and equi join? Any idea what is the difference between normal and equi? So see, sometimes in joining condition we also write other than equal to operator. So in joining condition we can also write less than operator, greater than operator, less than or equal to operator, greater than or equal to operator. So these operators also we can write in joining condition which are valid. We can write other than equal to operators also in joining condition, but we never write that one. But yes, this is also valid. You can also write other than equal to operator. So in place of equal to, if you write either of these operators, then we can call that as a normal join. Then we cannot call that as a equi-join. If you have other than equal to operator in a joining condition, then that is not a equi-join. So equi-join, it's mandatory to have only equal to operator. So then only we can call that as a equi-join. Normal join means it can have in joining condition equal to operator, less than operator, greater than, less than or equal to, greater than or equal to, less than, like all these operators. So equi-join should have only equal to operator, then only we can call that query as a equi-join query. If you have other than equal to operator in a joining condition, then we cannot say that as a equi-join. That is a normal join. Normal join will have all the operators, whereas equi-join will have only equal to operator. If we use other than equal to operator in a joining condition, then we can call that as a normal join. Okay, so that is the difference between normal and equi. So normal, when we call, if we have other than equal to operator in joining condition, then we should have to call that as a normal join. Then we cannot call that as a equi. Equi should have only equal to operator in joining condition. When that is normal or inner or equi join. Next, coming to left outer. Definition: what is left outer join? It returns matching records from, yeah, go ahead.
Matching rows from both the tables and non-matching records from left table.
Yeah, so it returns matching records from both the tables. Okay, and non-matching records from left side table. Okay, so this is left outer join. It returns matching records from both the tables and non-matching records from left side table. Okay, query: select star from employee e left join. So here you can write left outer join or left join, both are same, both are valid. Deptd on e dot department number is equals to d dot department number. So this is the query. Okay, so select star from the first table. This is left side table and this is right table. So whatever you write first, that is the left table, the other table is the right side table. So select star from this table, left join deptd on e dot department number is equals to d dot department number. So as per the definition, first it returns matching records from both the tables. Here we have the result set of matching records from both the tables. These three are the matching records from both the tables. Next, and non-matching records from left side table. So left side table is employee. So in employee, for what department number we have non-matching record. So for 10 we have matching record, for 20 we have matching record, for 10 again we have matching record, for 30 do we have matching record here? No, we do not have. So this record 4D30 is a non-matching record from left side table. Okay, so it is going to return like this: 30 department number 30. No, here we do not have matching record. Here we will be having null, nothing, blank. This is the output. Matching records from both the tables and non-matching records from left side table. So this is left outer join. Got it? Next, right outer join. So definition: matching records from both the tables and non-matching records from right side table. So matching records from both the tables and non-matching records from right side table. So this is the definition of right outer join: matching records from both the tables and non-matching records from right side table. SQL query: select star from employee E, right join DEPTD on E dot department number is equals to D dot department number. Got it? So you can write here right outer join or right join, both are same. So output: matching records from both the tables. So here we have the result set of matching records from both the tables. So these three are the matching records from both the tables and non-matching records from right side table. Right side means we have department table. So from department table, so we have to check like this: for 10, yes, we have matching record; for 20, yes, we have matching; for 40, do you have any matching record here? No. This is the non-matching record from right side table. You will be having output here null, 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 and here 40 finance. That's it. This is the output of right outer join: matching records from both the tables and non-matching records from right side table. Got it? This is right outer join. Next, full outer join. Full outer join. So this will return matching records from matching and non-matching records from both the tables. So it returns matching and non-matching records from both the tables. So matching records from both the tables, yes, these three are the matching records. First let me write the query: select star from employee E, full join or full outer join DEPTD on E dot DNO is equals to D dot DNO. This is the query. Okay, so then output: matching records from both the tables. These three are the matching records from both the tables and non-matching records from both the tables. So this is the non-matching record from left side table, 4D30 null null. So this is the non-matching record from left side table and this is the non-matching record from right side table. So this is your output of full outer join. It returns matching records and non-matching records from both the tables. Okay, so first three are the matching record, last two are, fourth record is non-matching record from left side table and fifth record is non-matching record from right side table. Got it? So these are the joins. Okay, in Informatica we write these join queries also to join multiple tables, not only accessing the data from single table. So we can also access the data from multiple tables by writing the join queries in Informatica. Right? So again in Informatica class we are going to discuss about these joins because we are going to write some join queries in Informatica. Fine. So that's why you should have to know what is left outer join, what is right outer join, what is normal join and all. Right? So if you practice this, you have to create the tables in a database and you have to practice all these queries. So if you practice all these queries and if you see the output, then only it would be easy to understand and it would be easy to remember. So if you are not going to practice just by listening, it's very difficult to remember, right? So whatever the queries we are discussing here, you should have to practice each and every query. And also in material you have more number of queries there. So now you are learning, right? So in at learning stage, so you should have to, I mean, like if you are attending the class for 2 hours, means you should have to spend time at least 2-3 hours for practice. So just by listening you will not get anything. So after listening you also have to do the practice. So that's the reason from the beginning I have been telling to practice, because once we start informatica, so if you are not going to practice on same day, then next day it would be difficult to understand the class, right? So these are the basics which we are discussing here. If you are good in basics, then definitely you can understand easily the complex scenarios. In basic itself, if you are not good, then it's difficult to understand. Fine. That's all about joins. I will send all these screenshots to you. Fine. Any questions here? Clear? Fine. Next we have very important interview question, or we can say 100% interview question from SQL. That is how to improve the query performance. Or query tuning. Okay, so this is very important interview question. Not only interview question, in working in real time, so most of the times you also have to involve in improving the query performance. Yeah. Yeah, a difference between materialized view and a table is, table will have all the columns, whereas materialized view will have limited number of columns which are not confidential, whereas actual table contains both confidential as well as the other normal columns, whereas materialized view will be created to access some of the columns in a table. So materialized view will not have all the columns from the actual table. That is the difference between view and materialized view. So materialized view also can be created to hide the confidential columns in a table. Got it? Clear? Vignesh, can you hear me? Vignesh, I'm not able to hear you.
Will views be faster when compared to tables?
Yeah, faster means yes, it's faster only, because I mean, like if you in table you will be having all the columns, right? Whereas view and materialized view you will be having limited columns. So if you write a query which is going to take less time to execute, selecting multiple columns data or limited columns data, obviously limited columns data selecting query will take less time to execute. Also reporting team, so we are ETL team. Yeah.
Will views be faster when compared to tables?
Yes, that's what I'm saying. Yeah, view obviously it will be faster, because there we will be having limited number of columns data, right? So selecting the all columns data, compare with selecting the limited columns data, which query will execute faster? Selecting less number of columns data only will execute within less time. Okay, so that is the reason, after loading the data in data warehouse, reporting team, to generate the reports, they need to create materialized views. So from the data warehouse data they are going to generate the reports. So while generating the reports, so they are not going to access all the columns data. So to generate reports they need to select some specific columns data, right? So if they are directly pulling the data from the data warehouse, if they are directly pulling the data from data warehouse, then queries will take long time to execute, because data warehouse contains huge data and all the columns. So that's the reason after creating a data warehouse, I mean like DBS will create materialized views. Now reports will be generated on top of materialized view tables, not on top of data warehouse data. So data warehouse there will be having a huge number of data and also like all the columns of data. So to generate report we don't want all the columns data. If you don't want all the columns data, then why you are selecting the data from directly data warehouse? If you are pulling the data directly from data warehouse, then it is going to affect on performance, reporting performance. So reports would be loaded very slowly. So instead of directly selecting the data from data warehouse data to generate a report, first you create a materialized view based on data warehouse data, and now you create a you generate a report on top of materialized views. So then your reports will be accessing very fastly compared with data warehouse reports. Okay. So when we are talking about performance, then definitely we should have to access the data based on top of materialized views. So if we directly select the data from a table, then it is going to affect on performance. Next, query tuning. So how to improve the query performance? Do you have any idea? Have you ever worked on performance tuning? Yeah, go ahead. Okay. 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 Mm-hmm. Any other tips other than explain plan? Cache the data at memory level. For what? Means. Okay. Okay, fine. Okay. Mm-hmm. Okay, fine. Thanks. Any other tips to improve the performance? No idea. Fine. So there are several steps to improve the query performance. We'll discuss one by one. So first one is initial analysis and make necessary changes. So we have to do the initial analysis of the query, and during the initial analysis wherever necessary changes are required, so we should have to make those necessary changes. What is this initial analysis and making the necessary changes? Like as we discussed in the last class, some of the developers like to search for a single value, they use in operator, right? So so you are searching for employee id 234, right? So you can write employee id in 345, this is valid. And also you can also write like this, employee id equal to this one, this is also valid. If you are searching for a single value, as we discussed, we should have to use equal to operator instead of in. So compare with equal to operator, in will take time to execute. So that's why whenever you have to search for a single value, you should have to use equal to operator instead of in. So you have to remove in. So sometimes developer will use this an in operator. In the same way, also as we discussed, if you are searching for name or any string, when we have to use like operator. So if you are not sure about complete name, or if you are not sure about this full string, then you have to use like operator. But here I have written full string here, right, whatever I am searching for. So if you have like this, then instead of using like operator, you should have to use equal to operator. So when we have to use like operator, if you are not sure about complete string, if you know only first character or last character, then you have to use like operator like this. Okay, so like operator, when we have to use, if we are not sure about complete string, then we have to use like operator. If you know about complete string, then we have to use equal to operator. Next, in sometimes, like even though if it is not necessary to join multiple tables, we use that table in a joining condition. For example, let's say I have three tables: select employee number, employee name, okay, department number, department name. From employee employee join deptd on e dot department number is equals to d dot department number. Join, we have one more table location l, okay, on, okay, so d dot department name is equals to l dot department name. Like this we have one query, and we have three tables like this: employee table, employee number, employee name, department number. And we have another table, dept department number, department name. I have one more table, location, where is the department. Okay, so here location id, department name, address. Like this we have some three tables. So we have three tables here, and in the select you can see here you are selecting the data from you are selecting the data from which tables? Employee table and department table. You have employee number in employee table, employee name in employee table, department number also there in employee table, department name is there in department table. So you are selecting the data from how many tables? From these two tables only. So if you are selecting the data from these two tables, why you have joined this table? So is it necessary to join this LOC table here? If you are not, I mean, like, if this query is returning the result same as without writing this join condition also, then what is the use of writing this joining condition? Okay, so like this we have to go through each and every line of the query. You have to verify whether this join is required or not. Sometimes we unnecessarily we write some of the joins. Sometimes unnecessarily we write some of the joins in the query. So that will also will take time. More number of joins query will take time to execute. So you have to go through each and every line of the query. So wherever unnecessary joins are used like this, then you have to remove this join. So before removing this join, you have to execute the query and see how many records this query is returning, and remove this join condition and execute the query, see whether it is returning the same result or not. If it is returning the same result, then no need to use this joining condition or join table. So you can remove this from the select query. And also sometimes we write we join like this, query within a query. Select employee number, employee name, or you can write select star from employee, okay, and we write query within a query, where department number is equals to, or department number in select select a department number from DEPT. So like this, suppose let's say we have a query like this, query within a query, subquery. Okay, so most of the times instead of writing this query within a query, it is suggestible to write join select a star from employee e join DEPT on e dot dno is equals to d dot dno. So instead of writing query within a query, you can just write a join. Okay, so this also will take less time to execute compare with this query. So like this, we have to go through each and every line of the query, and wherever like this necessary changes are required, so we should have to make the necessary changes. So this is the initial step which we have to do. Fine. Next, so after making the necessary changes, assume initially it is taking 1 hour time. So how much time it is taking? Initially it is taking 1 hour time. So after making the necessary changes and all, now if you execute this query, it is taking 50 minutes time. So after making the necessary changes, now how much time it is taking? Assume it is taking 50 minutes time. Second step, what we have to do? So we have to run the explain plan. After making the necessary changes, we should have to run this explain plan. What is this explain plan? Explain plan contains backend execution statistics of the query. What is explain plan? Explain plan contains backend execution statistics of the query. What is this backend execution statistics? So backend execution statistics means, let me show you one sample explain plan. So you can see the explain plan like this. So you have the explain plan here. Okay, so this is the query. For this query, this is the explain plan. Whatever the query here we have, for this query, this is the explain plan. So to generate explain plan, copy the query in a Toad. So in Toad only we write the SQL queries, right? Most of the companies will use Toad tool. So copy the query in the Toad tool. After copying, you should have to press Ctrl E. You just have to select this query and press Ctrl E. As soon as you press Ctrl E, this explain plan will be generated in Toad. Okay, so now if you observe this explain plan, you can see here you have backend execution statistics of the query, like cost of the query, bytes, cardinality, and hash join, write semi. Okay, and also we have table access full in red font, and here you can see table access by index, right? Index range scan index. So like this, we have some statistics of the query. What is the use of this statistics? Why we have to run the explain plan? So by seeing the cost here we have cost 8000, right? 8003. So by seeing this cost, we can estimate the execution time of the query. We can estimate, not exact time, we can estimate the execution time of the query. If the cost is 8000, that means this will take little, when like a 2 minutes or 3 minutes time to execute. If the cost is at 50,000 or 1 lakh or 2 lakhs or 5 lakhs, sometimes it would be in kbs or sometimes it would be in mbs. So if the cost is high, if the cost is in lakhs, then definitely that query will take long time to execute. So by seeing this cost before executing the query, by seeing this cost, we can estimate the execution time of the query. If the cost is in within less than 10,000 or less than 5,000, then definitely it will take less time to execute. If the cost is in lakhs, then definitely it will take a long time to execute. So by seeing this cost, we can estimate the execution time of the query. Next, come here, we have table access full. Okay, in red font you can see table access full, and for some of the table here we have table access by index. What is the difference between table access full and table access by index? Means, for example, let's say here you have an employee table here, and employee table, employee number, department number 1 E10, 2B20, 3C10, 4D20, 5E30. Like this we have one employee table. Now in your query you are searching for department number is equals to 10. You have one query, and in your query you have a condition department number is equals to 10. Okay, so you are searching for department number 10 in employee table. So what it will do, it will go to this employee table, it will check for the first record department number, whether is this 10 or not. Is this 10? Yes. Now this is matching, it will return this record. Next it will come to the second record, it will check whether this department number is matching with this 20 or not. Is this matching? No, this is not matching. Next it comes to third record, it will check whether this record is matching with this 10 or not. Now this is matching, yes, this will return this record. Next it comes to fourth record, it will check whether this 20 is matching with 10 or not. This is not matching. Next it comes to fifth record, so it will check whether this 30 is matching with 10 or not. It is not matching, so it will not return this record. Okay, so like this. Now how many records it has scanned for matching record? How many records it has scanned? Total how many records are there here? 5 records, right? So it has scanned 5 records. Okay, so if you have 1 million records, suppose let's say if you have 1 million records in this table, to search for a department number 10 record in employee, how many records it will scan? 1 million or only 5? If you have 1 million records in this employee table, if it is searching for department number 10, so it will search all 1 million, right? It will search for all 1 million records. Okay, yeah, so it will search for all 1 million records. So out of 1 million, if you have only two records belongs to 10 department, assume out of 1 million we have only 2 records belongs to 10 department. Even though you have 2 records belongs to 10 department, how many records it is scanning here? All 1 million. So will it take time or not to execute? Yes, definitely it will take time, because even though we have only 2 records belongs to 10 department, it is scanning full table. Why it is scanning full table? So as per the process, it should have to check record by record. Wherever the matching record found, it is going to display that record, matching record. But here it is scanning full table. So record by record, it is scanning full table. So why it is scanning full table? Because there is no index created. Because of no index, it is scanning full table. For example, in our textbook, we'll be having index page, right? In initial pages, we'll be having index page, right? You have one textbook of 1000 pages. You have a textbook of 1000 pages and you don't have index page. You want to search for a specific topic. You don't know in which page that topic is there. Okay, and there is no index page. So if there is no index page and if you are not sure in which page that specific topic exists, then what you are going to do? So you are going to scan, or you are going through page by page, right? So you have to verify all the 1000 pages, right? So why you are verifying all 1000 pages? Because there is no index page. If there is an index page, then are you going to scan all the pages one by one? No, right? Okay, so you are not going to scan all the pages one by one, no, right? So directly you will be going to like index page. From there you will get the page number and directly you can go to that page, right? So there, if there is an index page, we can improve the search performance. In the same way, here also, since there is no index created on top of this department number column, it is scanning all the records from this employee table, all 1 million records. So if you have index, then directly first it will go to the index. From there it will take the page number, directly it will go to that page. In the same way here also, since there is no index created, it is scanning full table. So you can see the same thing. Still you can't hear me? Can you hear me? We have to create index on this employee department number column. So whatever the column we are searching, so on top of that column we have to create an index. So who will create the index? We are informatica developers. Okay, it's not our responsibility to create the index. As a informatica developer, we have to suggest our team lead, or we have to request a DBA to create an index on department number column. Okay, so just in the second step, by running the explain plan, we will come to know execution statistics. I mean, like, we can see the execution statistics, and we can decide on which table index is created and on which table index is not created. So whatever the tables are there which are not having the index, then we have to request a DBA to create a index. So as soon as we request a DBA to create an index, DBA will start creating the index. So third step is creating the index. Second step, run explain plan and decide on which table index is there and on which table index is not there, and on which table we have to create the index. Okay, so third, create index. So third step is we have to create the index. Okay, so this can be done by DBA. So if you have an idea, then you can run the explain plan, you can request, you can send email to DBA to create the index. So DBA, now they will start writing a query to create a index. As soon as they write a query to create a index, at the back inside the server, index page will be created like this. I repeat, as soon as they execute a query to create a index, at the back inside the server, index page will be created. So this index page will have two columns. First column is value, the second column is address. So this is index page, employee index. Okay, so employee index page, value and address. So as soon as they execute a query to create an index, at the back inside the server, index page will be created, and this index page will have two columns, value and address. And in value column, whatever the column you have used to create an index in a table, suppose let's say now here we have decided to create an index on department number. So from this column it will select the distinct values and it will insert those distinct values into this value column. I repeat, as soon as the DBS execute a query to create an index, at the back inside that server, index page will be created. This index page will have two columns, value and address. In value column, it will select the distinct values from index column in a table. So index column in a table is department number. Okay, from that it will select the distinct values and it will insert the distinct values in this value index page. And then for each and every value, it will assign the addresses, unique address. For each and every value, index automatically it will assign a unique address, something like this, ABC. So like this, some unique address it will assign for each and every value. So with this, index page is ready. Okay, so now we have index page. Assume in textbook you have index page. Okay, you have 1000 pages and you have index page. So if you have index page and if there are no page numbers, you have index page and there are no page numbers, then what is the use of having index page if there are no page numbers, right? So that also no use. So that's the reason we should have page numbers also inside the textbook. In the same way, here also, after creating an index page, automatically it will give the page numbers to the table. How it is going to give the page numbers means, it will create the page numbers like this in a table. So we are not going to create all these things, just to know what is index and how it is going to be created and how it is going to be executed. I'm just showing. So it is going to create the page numbers like this for 10, 20, 30. For each and every value, it will create one column, 10, 20 and 30. So like this, it will give the page numbers. Wherever 10 is there, what is the address of 10? ABC. So here we have 10, here it will give ABC. Next, ABC. Okay, so next 20, here we have 20, here it will give XYZ. In the same way, here it will give XYZ. Then 30, here we have 30. So 30 like this, it will give the page numbers at the back automatically. We are not going to give this page numbers. So automatically Informatica, SQL Oracle will give the page numbers as soon as they execute a query to create an index. First, at the back inside the server, index page will be created and it will give the page numbers like this. Okay, after creating the page, now if you execute the query, so now we are searching for department number 10. So before going to search for department number 10, queries will check is there any index created for this employee table. Okay, so if there is an index created, it will go to the index page for 10. We are searching for 10, right? It will take the address of 10 and it will go to the 10 column. Okay, and it will search for the address ABC. So it will take the address of ABC, address of this 10 from index page, and it will go to the it will go to the table 10 number column, and here it will search for ABC. How many ABCs are there? Only 2. So now how many records it will scan? All 1 million or only 2? How many records it will scan? Only 2. So earlier, before index, it was scanned how many records? Even though we have 2 matching records, it scanned all 1 million records. Now here, after creating index, based on this index page, it will go to the 10 column, and from there it will search for ABC. So how many ABCs are there? Only 2. So it will select those 2 corresponding records. So how much time we have increased here to, how much time we have consumed to improve the performance? So earlier it was scanning 1 million records. Now it is scanning only 2 records. So this is how we can improve the query performance by creating an index a lot. Okay, so that's the reason. So indexes are very important to create to improve the performance. So if there is no index, then definitely it will take a long time to execute. So that's the reason, make sure index is created if the query is taking long time to execute. So one of the important step to improve the performance is creating an index. So while creating index, we have different types of indexes like B-tree index, binary, or like we have different types of indexes. Okay, bitmap index, right? So like this, we have different types of indexes. Depends on column. Some suppose let's say we have a column called gender. We have a gender column. So even though you have millions of records, in gender column you will be having only 2 distinct records, either M or F, right? Okay, so on top of that gender column, so that column we called it as a low cardinality. Low cardinality means low distinct values, very less distinct values. Sometimes we will be having flag column, either 0 or 1 or yes or no, right? So like this, if you have low cardinality columns, on top of low cardinality columns, they will create bitmap index. So which type of index will be created on top of low cardinality column? Bitmap index, right? Okay, so now here department number. So in this table we have only 3 distinct, 10, 20 and 30. Sometimes we will have some 10 departments or 20 departments or 50 departments, right? So in that case, they might create binary index or B-tree index. Okay, so depends on requirement. The DBS will decide what type of index they should have to create. We are not the responsible persons. Okay, in interview if they ask, do you know any type of indexes, then you can tell B-tree or binary or bitmap index. Okay, that's it. So now you have seen here, after creating index how much performance we have improved, right? So we have improved in performance a lot. Earlier it was scanning all 1 million records. After creating index like this, it will go to the index page first. From there it will take the address, and then it will go to the table, and where whatever the value we are searching for, it will search for that column here. Okay, and in this column it will search for this addresses. We have only two addresses belongs to ABC. It will fetch only those two records, not all 1 million. So like this we can improve the query performance by creating an index. Fine. So we have created an index, and after creating index, now query is taking 30 minutes time. Earlier it was taking 50 minutes time. So now we have improved the performance. Now assume it is taking 30 minutes time. Still I want to improve the query performance. So after creating index, still if you want to improve the query performance, then table analysis. So what is meant by table analysis? Table analysis means this table analysis generally we have to perform after creating an index. So this also can be done by DBA. So table analysis also can be done by DBA. What is meant by table analysis? So table analysis means sometimes here we have the address for 10, it is ABC. While assigning this address in a table, instead of ABC it will assign like this ABD, some junk address. In index page we have address for 10 is ABC. The same address you should have to assign in a table. Okay, so instead of ABC it will assign some junk address. Sometimes this will happen. Okay, so if there are junk addresses like this, then what it will do, if you execute a query to search for a department number 10, it will take the 10 address ABC, it will go to the 10 column, it will search for ABC. Here how many ABCs are there? Only one. The second record we have ABD, which is also a matching record, right? We have the same 10 department for third record also, this record ABD record, but the address doesn't match. So if the address doesn't match, then what it will do, it will compare the values whether these values are matching or not. First, by default it will compare with the address. If the addresses doesn't match, then it will compare with the values. Again it will come back to the index, it will take the value and it will search the value in department number column for this invalid address. Now if that value is matching, it will display that record. Finally it will display that record also, but here it will take time because of that invalid or junk address. Okay, so if there are any invalid or junk addresses like this, so if we do the table analysis, they will be having some tool, DBA will be having some tool to do the this table analysis. So if they are going to execute the table analysis, then what it will do, in these indexes will be reorganized. So whatever the invalid addresses are there, so these will be reorganized by updating the valid address. Even though after creating index, because of that invalid address, queries will take time to execute. So by doing the table analysis, again indexes will be reorganized, and wherever the junk address or invalid address is there, so those addresses will be updated with proper address. Now we have ABC, now it will take less time to execute. So that is table analysis. So table analysis means it will reassign or it will reorganize the indexes. Wherever the invalid address or junk address is there, it will update the incorrect or junk address with proper address. That is table analysis. Next, fifth step. So after doing the table analysis, let's say now it is taking 20 minutes time. Still if you want to improve the query performance, so fifth step we have to do hints. So hints we have to do only after creating an index. So before creating index, like without having an index we cannot use hint. So hints when we have to use the hint only after having the index on top of the table or a column. Okay, what hints will do? Hints will not allow index to create the cache. What hints will do? Hints will not allow index to create the cache. How to create a hint? Who will create a hint? We are not going to create any hints. Hints, just you have to write the statement in your select query. After select, you should have to write slash star plus parallel of 4 star slash. This we called it as a hint. This is a parallel fourth degree hint. What is this? Parallel fourth degree hint. Even though this is in comment, this we called it as a hint. This is parallel hint, parallel fourth degree hint. So if you write like this, then what it will do, like if there is no hint, generally index, what it will do, as soon as the now you are searching for 10 department, it will go to this table. Here we have two ABCs. So first it will insert the first matching record in a cache. So index first it will create a cache, means temporary table will be created. In temporary table, first it will insert the matching record, first matching record 1A10. Next again it will go back to the table, it will search for second ABC. Here we have second ABC. Yeah, second matching record we have, it will select the second matching record 3C10. So selected second matching record, inserted in the cache. Again it will go back to the table and it will check, is there any third matching record? Do we have third matching record? No, we do not have. Okay, so now it will come to the cache temporary table. From there this will select the data and it will display to the output. I repeat, indexes, what they will do? Indexes will create a cache, means temporary table will be created. It will select all the matching records from the actual table and it will insert those matching records into the temporary table. From there it will select and it will display to the output. Whereas if you write parallel hint in the select query, parallel hint will not allow index to create the cache. Parallel hint will not allow index to create this cache. As soon as the matching record found, it directly displays to the output. Don't create the cache, don't insert the record into the cache, don't select the record from the cache. Creating the cache will take time, inserting the records into the cache will take time, again fetching the records from the cache, it will take time. So instead of doing all these things, as soon as the matching record, why need to create the cache? Directly display to the output. Right? So if you want to select the data from cache, then no need to use hint. If you don't want to select the data from cache or a temporary table, directly as soon as the matching record found, if you want that record to be displayed to the output, then you have to write select parallel degree. This parallel you have to write in the select statement. Got it? So just by writing this parallel, you can execute the query performance. I mean, like you can improve the query performance. Right? So after using the parallel hint, you can also see the difference in cost. So without using parallel hint in select query, if you have the cost of 15,000, after writing a parallel, you can see the cost, now it is 2,000 or 3,000. So that much of difference you can see. So without using parallel hint, if the query is going to have the cost of 15,000, after using the hint, again if you generate the explain plan, that time you see the difference in cost. So definitely now you will be having 2000 or 3000. Compare with 15,000 to 2000 or 3000, definitely query will take less time to execute. So that is the reason we also have to write hint in the select query. Right? So this we call it as a parallel hint. You just have to write parallel, that's it. So that we call it as a parallel hint. So parallel hint will not allow index to create any cache. As soon as the matching record found, directly it displays to the output without storing anywhere. Where if you do not use hint, then index will create the cache. There it will store all the matching record. Once we have all the matching records, from there it will select and it will display to the output. Fine. Next. So after creating a hints, now I mean like after using the hint in our select query, now the query is taking 10 minutes time. Still I want to improve the performance. The final step, we have to go for partitions. So final step, we have to go for partitions. What is meant by partitions? So partition means increasing the readers count. What is meant by partition? Partitioning means increasing the readers count. So suppose, let's say for example, we have 1 million records in our table, and out of 1 million we have 1 lakh matching records. How many matching records are there? We have 1 lakh matching records. Out of 1 million we have 1 lakh matching records. By default, to read the data from the database, we would be having only one reader. To insert the data into the database or a table, we would be having only one writer. So one reader will read the data and one writer will write the data into the table by default. Okay, so if you create two readers and if you use those two readers to run parallelly, then definitely we will improve the performance, right? Okay, suppose we, as we discussed, like we have 1 lakh matching records. Now I have created two readers, and if I set the range to each and every reader, first reader read the records from 1 to 50,000, second reader read the records from 50,000 to 1 lakh, and if these two readers are going to run parallelly, then definitely it will take less time. So now let's say after using hints, it is taking 10 minutes time. So I have created a partition. After creating a partition, that means I have created two partitions, and earlier before partitions, to read 1 lakh records, it is taking 1 minute, 10 minutes time. One reader is taking how much time to read 1 lakh matching records? 10 minutes time. Now, so now we have created two partitions. So after creating two partitions, and first partition we have set the limit as 1 to 50,000, and for the second partition if you set the range 50,000 to 1 lakh, then how much time now it is going to take? How much time it will take now? If I create two partitions, 5 minutes. Yeah, half of the time, right? So 5 minutes it will take. So definitely we can improve the performance here by increasing our readers count or by creating the partitions. So now here we have created two partitions. If you create three partitions, for the first partition if you set the range 1 to 30,000, 30,000 to 60,000, 60,000 to 1 lakh, if you set like that, then again we can improve the performance. Like now, with two partitions it was taking 5 minutes time. If you create three partitions, it will take 2 minutes or 3 minutes time to execute. So it is not like that we have to create 100 partitions. No, it is not suggestible. First you have to tune the query, you have to create indexes, use the hints, then final stage we have to go for partitions. In the first stage itself we should not go to the partitions. We have different types of partitions like database partition, round robin, hash partition, right? So we have different types of database partitions, and also in informatica we have option to create the partitions at informatica level. Database level partitions, it's not the informatica developer's responsibility. Database level partitions, it's DBS responsibility to create database partitions. At informatica level, yes, it's informatica developer's responsibility to create the partitions. So informatica level creating the partitions, that we will discuss in detail in informatica class. I will show you how to create informatica level partitions and what type of partitions we have in informatica. Like we have pass through partitions, key range partition, like this we have different types of partitions in informatica. So that we will discuss in informatica class. So here partitions, to increase the readers count, we can create the partitions and those readers will run parallelly and it will take less time to execute. Also it is not suggestible to create the partitions. It is not suggestible to create the partitions like 100 partitions or 200. No. So if the business says if they are fine with 2 minutes, you can stop there. So if business says it should have to take only 1 minute, then you can create one more partition. That's it. Max 3 or 4 we can create. It's not like that hundreds of partitions we have to create. No. Right? So these are the different steps we have to improve the query performance. It's not like that we have only these steps, we can also have other steps also, but these are the major steps which involve to improve the query performance. Clear? Any questions here? Okay, so this is very important interview question. They might ask like, have you ever involved to improve the query performance? Okay, so you should have to say yes. As an informatica developer, sometimes it is necessary to verify the query performance also. Okay, fine. So you have to explain all these steps. Fine. Any questions? Fine. So that's all for the day. We'll continue tomorrow. Okay, so with this we have completed SQL. Okay, so tomorrow we are going to start PLSQL. So PLSQL only one day. So tomorrow itself we are going to finish the PLSQL, just half an hour class. Like I'm going to just explain what is PLSQL script, how to create a script and how to execute the PLSQL script, and what is stored procedure, how to create a stored procedure, how to execute the stored procedure, how to call that procedure in Informatica. So these things we'll be discussing in PLSQL class. So SQL, this is more than enough. Fine. So you practice whatever we have discussed from SQL, and if you have time, so you can also refer the material, SQL material. So there you can there you have many number of examples. You can also practice those things. Fine. So that's all for the day. We'll continue tomorrow.